Okay, we just finished 2.6, domain and range. We're going to take a look at function operations now. Now I've color-coded a little bit just so you can see, if necessary, which function is which. So, for the purposes of these exercises here, let's let f of x be x plus 2. I'll use red and green for my g of x, x minus 3. Find these. Now, this literally means take your f equation. I think of this, by the way, as f of x plus g of x, okay? I think people do that notation when they're typing only, just because it's shortcut, but I understand it to mean whatever it is. Anyways, you literally will take your x plus 2 equation. I use brackets even though it's not necessary because it's the first thing, but it's a good habit because if you're ever subtracting, that's the most likely error, right? But we're adding x plus x is 2. I'm sorry, what's that?
Why is it x in the back? Also multiplied by x.
Ah, that's what I was, okay. This notation means f plus g of x, and it really means f of x plus g of x. So yeah, don't think of it as multiplied. That's what I wanted to show there. Had you guys seen this notation much before?
Well,
Textbooks do it, but I always use this notation. And like I said, I think it comes back from like pre-2000s and stuff when people would actually type with typewriters and stuff like that. I don't know why it's used. But, okay, my 2x doesn't look like an x, so 2x. 2 and minus 3 is subtract 1, okay? Now, the next one, I'm going to skip the notation step like this. I hope we understand this next one to be f of x minus g of x. We'll jump straight into it. This, like I said, is why I use brackets. X plus 2, subtract my g equation. Most likely error is not subtracting minus x minus negative 3, like not subtracting through the whole bracket. But my x's disappear, x minus x. Then 2 minus negative 3 is actually adding, so 5. Do you understand? F of g, or f times g of x, I mean, means multiplication of the two. And I'll just close this, guys. Or wouldn't I take advantage of the technology here? And then you can square it out. Or square it out, not square it out. X squared minus 3x plus 2x is subtract x. And we group the like terms and subtract 6. Clone. Clone. A cheater, eh? Ah. I didn't even mean to do that, but whatever. I'll undo that because I don't like the typing. Anyways. I'm not going to ask you to further divide that with a remainder and all like that, okay? But that's what that represents, f over g of x. The really important one, though, is composition. Now, we will take a moment to try out composition. The order does matter. Now, you could do it with evaluations, or you could do it with just plain old x. What does it mean to be f of g of 1? FOG looks like fog. This, I like rewriting it. I'm rewriting it like this. This is what I handwrite. F of g of 1. So what do? You take 1, you put it into the g equation, right? 1. 4 over 1 minus 3, right? And you are literally, and you can do this as a thinking step, but 4 over 1 minus 3. I'm figuring out what that is. It's 4 over 2, negative 2. So it's negative 2 altogether. 4 over negative 2 is negative 2.
What does that circle thing mean?
This means f of g. This is probably how you've seen it before. Is that right?
Yeah.
The g equation inside the f equation. Everybody's clear on that? Because people seldom handwrite it, but you'll see the textbooks that way. Think f of g of 1. Put the g inside. I guess I should have switched my 4s and stuff to be green. I actually use the g equation in there. Do the arithmetic. F of, like I said, I should have wrote that. Negative 2, which I got out of the g equation, right? I could do that still. Okay, so where did I get this from? G. Once I put negative 2 into this equation, we're set. Negative 2 squared, subtract 1. So 4 minus 1 is 3. Now, I showed a lot of steps there because I'm trying to instruct you. I wouldn't doubt that you could take a look at this, many of you, and say, well, f of g of 1, that's like putting negative 2 into the f equation, which when I do the arithmetic, I can just write down 3. I'm fine with that. Do show something mid-step, though. If you're worried about losing marks, show more. And if you do some quality work in between, I can give you half marks or something like that. If you're prone to make mistakes. Now, f of negative 2. So this means the function with the function inside of it. Right? Now, I wouldn't normally write this out. I'd do the arithmetic in my head, I think, but I'm going to show you what I mean. I'm taking f of negative 2, so negative 2, which we've already worked out, squared minus 1. I'm putting that. So I'm figuring out what negative 2 squared minus 1 is. We already figured it out. It's 3. F of 3. Now, do you guys follow this? Function inside itself. Now I'm putting 3 in for that, right? So 3 squared, 9, minus 1 is 8. So arithmetic isn't too bad to do, I'm hoping. Here's open. And then, what about, and you've done these before, but they get crappy. F of g of x. So we are literally putting the equation inside the other equation. I'm thinking of this as f of g of x. This means, I'm going to back up a step here and remind us, because some people, no problem with this, some people, not quite. What did it mean? Let's just circle when we had a number. F of negative 2. My green negative 2, what did I do with that? Anywhere I saw the letter x, I replaced it with negative 2, right? So anywhere I see the letter x in the f expression, I replace it with the g equation. Does that make sense? Makes sense to Ava. Okay, you guys too? Okay, if you're wondering about this, and I know you took it, I think, in the second last chapter of Pre-Calc 30. So some people it's fresh, some people it was last year. This is probably one of the more important skills. Factoring is definitely the most important skill to your success in calculus. This is a huge skill, identifying composition and stuff, because remember the chain rule? She knows what I'm talking about. Anywhere you see the chain rule, you're got to be able to identify function composition. Now what I just wrote down is, would you guys agree, the f expression with something left to replace it with, right? This x is really just a blank, right? Something squared minus 1. And in this case, my g is what I'm going to put in there, right? So I can put my something squared. 4 over x minus 3. Hot diggity dog. I could go to town with that, get common factors and stuff. Hey, why not? Why not? I don't want to. Well, I'm going to. 16 on the top. X minus 3 squared. Okay. Just distributing the square, right? Now, minus 1. We need common denominator. This is x minus 3 squared over x minus 3 squared. Now, so here's a common denominator. Now, x minus 3 squared. Now, I'm going to keep this here, though. X minus 3 squared is understood to be on the top, right? But I said I'm not going to keep this on. I thought that would be detached. I'm going to replace that with the full expression, x minus 3 multiplied out, squared. Why? Because I already know I've got a group like terms with a 16, and that factor won't work. Now, if you wish, write it down right now as x minus 3 squared, and then do this on a separate step, okay? But I'm going to do it right now. So x times x minus 3 times x minus 3 is what I'm figuring out. So I've got x squared minus 3x plus negative 3x is minus 6x. Minus 3 times minus 3 is plus 9. I'm keeping in mind that I'm going to distribute the negative sign. When I do the arithmetic and group the 16, subtract 9. This just doesn't end. I don't know why I chose to actually punish myself and keep this going, but whatever. 5, 7. Oh, this is easy. Minus 9. Yeah, it subtracts 7. Okay. Oh. Okay, we're going to take my signs, right? Minus x squared, good. Plus 6x, that's good. Minus 9, 16 minus 9 is 7, negative. 16 minus 9 is positive. Okay, good. Got it. Don't I? I'm supposed to factor that. You could. You take out a negative sign, and everything would be opposite again. Boy, these negatives are getting me down. Then, if I had x squared minus 6x minus 7, I could see it was x minus 7 plus 1. So it could be factored in this case. Most don't actually factor out this nice. And I would be the same as with nice. Time consuming. Or whatever. The next one we won't work out further. Just because I'm tired. My head hurts. Now, what's the idea with g of x? I'm putting the g equation inside the g equation. Meaning, anywhere I see. Oh, first, errors. Nothing? Good, I did catch my one negative sign there. And vice. Okay, 4 over x minus 3 is what the g equation is. So this means 4 over something minus 3. I think of it this way. What is that something we got in the inside? It's the g equation again. 4 over. So like a looking glass, you know, a mirror with a, you ever point a mirror at a mirror? You see the mirror inside? I don't know. So like this is inside this, which is, you could go on forever then or something like that. Put that inside another thing. We'll leave it at this, okay? Yeah. Thank me, because I don't want to do it. Yeah. I'm not stupid. Okay. Now this way around here. 3 equations, tossing them inside each other. Or no. Okay. Pull these apart. And this is the important skill for calculus, sorry. So, find the 2 functions that you could consider this. So that f is the outside function, g is the inside function. I'm thinking this. When I see this, I think f of g of x. So what we're trying to do is call this h of x. Anyways, I'm sweating, no wonder why. I'm not the only one.
How do we open it?
Yeah, like the old twisteroo.
This, I opened it.
Some ways you could think of these, they're not so useful, some ways aren't. We're thinking, what's the inside function, we'll call that g, what's the outside function? So what I'm talking about here is, would you guys agree that this looks like something to the power of 4, and then inside it is the 2x squared stuff? So what I'm going to say is, my g of x here, my inside function is 2x squared plus 3x. And I've got that inside f of x. That looks like just something to the power of 4, so I'm going to call it something x. You guys see that? Some of these sometimes have more than one way to do these. And Hashim, you can assure these people that being able to identify this is important with the chain rule, right? Because you're going to say 4x and then do the derivative of the inside function. It is important. Now, what is the outside function, Kennedy? What does the outside function look like here for B?
I have no idea.
Okay. Does it look like there's a distinct inside and outside when I look at this and I know Hashim? Now here's something, and does this look like it's the inside of that? So this is what you're trying to separate. I think the inside and the outside. The outside would be root 5, and the inside would be sine 3x. I could identify 3 different things though. I could even think of this as 3x is inside sine, which is inside.
Yeah.
I'm going to break this even though it wasn't asked for 3. I'm going to break it up into 3 parts. So I'm going to just to show you, because the exam, the outline that I have has 3 parts of it. So I'm going to even say E, F, G, H. Oh, I guess H is used. I'll call this J of x is equal. So that's even inner. 3x and g is the sine function, sine of x, and then the outsidest of the functions, f of x. 5th root. If you want to put 1/5 there too, you could do that. Now this last one here. You might be thinking, well, it's not too much inside. Well, you can't think of it that way. You could think of this as 4 divided by something.
Yeah, that's fine.
So I'm going to say 4 over x is the outside function. Inside that, I've got 2x plus 7. Okay? So the inside, 2x plus 7. The outside. There you go. let's try this A out. So what do we do here? This is the function f of x plus g of x. And I've got a graph. Here's my f. Here's my g. Okay? So all I do is I think, I'm waiting for that to see here if I've got the right pen. It's good, it's not that kind of, you know, that color comes up. Anyways, well, let's start at f of, f is the top function there. Well, -5, I guess, makes sense. So f of -5 is 2. F of or g of -5 is subtract 1, so 2 minus 1. Okay. Oh,
Are we trying to draw another?
yeah. We're trying to draw the, and I'm going to just cut, not cut. I'm going to hold this, lock this in place here just so it doesn't move like that again. Okay, we're trying to figure out, if you want to call it h of x or something, what would the graph of f plus g values look like? So I take the f value of 2, oh, right. Take the f value of 2 and add it to -1, and when I add 2 and -1 together, I get, I'm going to put them both there, right? That's what I get. Now, when I look at 3, or -3, sorry. I used blue before, so maybe I should use blue. So when I do this one, I got -1 and +1. I'm looking at x equals -3. So they add up to 0, right? So I'm going to 0 it off. When I do the next one, here and here, I've got a depth of -2 added to +1, so negative, you know what? Yeah, -1. I'm going to put my green here, my sum, -1. I guess I skipped a value, didn't I? -4. Well, I've got -1 here, and I've got half, 1.5 here. So it's going to be half. Sorry, I did out of that one. So then what? Do you guys get the idea what you do with these?
Yeah.
Okay. Continue on. The other one you multiply for c, you see there. Now, f of g of x is a little trickier. Try that out too. Okay? Try those out. Definitely think this through a little bit, and then try those assignment questions out too. Okay? Question?
Did you do the assignment questions?
I'm going to hand those back to you.